Hi, this is a recorded lecture for the DP Design Technology topic 3.2 Graphical Modeling. First of all, graphical modeling is a visualization of an idea often created on paper or through software in 2 or 3 dimensions. And this is important from the IB. Students are expected to develop graphical modeling skills that allow them to demonstrate competency in a number of modes and media, including sketching techniques. So that's going to be the most sort of basic drawings that we do, and then formal technical drawing techniques that include orthographic, two-dimensional, three-dimensional, and then we're talking three-dimensional here. We have different types of perspective models, different types of projections and scale modelings. We have to also think about part and assembly drawings, including exploded diagrams. Another type of graphical model that we might also look at are data models. And so data models are a model that determines the structure of data, and it represents data in structural relationships. It's relevant for information design, software development, and database management. So basically, how can you represent data in a way that is pictorial, that can be understood by people? We have two-dimensional graphical modeling. So this is examples of two-dimensional graphical modeling. We have 2D sketching, and then we have formal drawing techniques. Formal drawing techniques, this is a type of drawing technique that has fixed rules, and the most widely used being isometric projections and perspective drawings. So this is an isometric projection, and this is a perspective drawing. Perspective drawings are a set of formal drawing techniques that depicts an object as getting smaller and closer together the further away they are. The techniques are 1-point perspective, 2-point perspective, and 3-point perspective, and we'll go through each of these as we go. By the way, this drawing technique was developed in the Renaissance in Italy, and like for instance, Leonardo da Vinci was very famous for his perspective drawings. 1-point perspective is where you have a single point where all the lines converge. So one single point perspective uses objects facing the viewer and receding to a single, often central vanishing point. So the point where all the lines converge is called the vanishing point. And on this drawing, it's going to be somewhere back here. But you can see that all of these horizontal lines are converging on a single point. One of the ways that I can tell that I'm looking at a single point perspective drawing compared to a 2-point or a 3-point perspective drawings has to do with the vertical lines. So if you look at the vertical lines, they're all parallel, right? They're not converging. So that's one way that you can tell that this is single point or 1-point perspective, because all of the horizontal lines are converging on a single point and all of the vertical lines are parallel to each other. If we compare that to 2-point, you can see that we have a little bit of a different situation here. In 2-point perspective, you're going to have 2 perspective points where all of the horizontal lines are receding into 1 or 2 vanishing points situated on the horizon. This is a convention most often used in architectural drawings, so you can see that the horizontal lines here are converging on this point, and the horizontal lines here are converging on this point. And again, you can see that the vertical lines are all parallel. So to tell the difference between 1 and 2 perspective, you need to see that the horizontal lines are not converging on a single point, but they're converging on 2 points. So 1 to the left, 1 to the right. 3-point perspective is, of course, having 3 points where the lines converge. So 3-point perspective incorporates a third vanishing point that appends to the vertical axis, receding either downwards or depending on the viewer's standpoint. Now, one of the things that I use here to distinguish this between 2-point perspective is you can see that all of the lines now are converging. So the horizontal lines are converging here and here, and the vertical lines are converging here. So that's what makes this a 3-point perspective. We also have projection drawings. So this is a system of drawing that are accurately drawn. The 2 main types are isometric. So this is an isometric drawing, and this is an orthographic drawing. And we'll go through each of those right now. So when we look at orthographic drawings, these use line of sights that are perpendicular to the viewing plane or face to produce a projected image. It's a bit like tracing a cast shadow. So if you think here, if we were to trace the shadow right here, we would just get the line from this plane right here. So it's a straight on side view. So if you think of this These are orthographic drawings. This is showing the top view. This is showing the front view. This is showing the right side view. You don't see any other side. In the front view, you're not seeing the right side and the left side or the top or the bottom. Compare that to an isometric drawing. On an isometric drawing, you're seeing this side and this side and this side. So really, you're seeing the left side, the right side, and the top side here. Whereas with an orthographic drawing, you're only ever seeing one side at a time. And like I say, it's a bit like casting a shadow. Isometric drawings could also be called third angle drawings, and it's a method of graphic representation of three-dimensional objects. In this technique, it is intended to combine the illusion of depth, as in a perspective rendering, with the undistorted representation of the object's principal dimensions. That is, those parallel to a chosen set of three mutually perpendicular coordinate axes. So in short, if you remember with the perspective drawings, you have vanishing points. So you have lines that are disappearing and not parallel to each other. But if you look at an isometric drawing, the lines are always parallel to each other in any given direction. So, this one and this one and this one and this one are parallel to each other. There's no vanishing point. So that maintains the dimensions, and that's what they're talking about here. It's an undistorted representation of the object's principal dimensions. We have working drawings. So working drawings are used to guide production of a product, most commonly orthographical projections, section drawings, part drawings, assembly drawings, and plan drawings. So this right here in total is a plan drawing, and it's composed of orthographic, and it's got also different sectional drawings, part drawings, assembly drawings. So let's talk about part and assembly drawings. Part and assembly drawings are drawings that show the relative size and position of all the parts, fastenings, and functional relationships between them. Okay, so this is a part and assembly drawing right here. And it's got some different aspects to it. Part drawings are orthographic drawings of the components of an assembly containing details just about that component. So this is a part drawing right here. It's an orthographical drawing, and it's telling you about this particular component. If I look at an assembly drawing, this is a diagram that shows how components fit together to make a whole, and it's typically represented in an exploded view, and also this is an isometric view right here. So you can see that how everything fits together. You can see where the bolts are, you can see where this top piece is, the bottom piece is, and these interior pieces and how they fit together. Exploded assembly drawings look like this. So this is an exploded isometric drawing that shows components displaced or exploded along the assembly axis. So you can see that right here. You can see how this goes into here and etc. So it's going to just show you how this is assembled. This is a clock, right? This is the minute hand and the hour hand and the locking nut and the washer and the acrylic body and the mechanism casing and the mechanism shaft. So it's showing you these, and it has these assembly lines right here. Scale drawings are drawings that are sized by specific ratios from the actual size. For example, if I had a 1:5 ratio, that would mean that 1 centimeter in the drawing would represent 5 centimeters in the real world. So this is an example of using graphical conceptual modeling in the real world. It's wireframing for UX interface, and this is from Google, and it's actually really pretty interesting to see how people use graphical models in ways that you might not expect. There are some advantages and disadvantages to using different types of graphical models. So for instance, orthogonal drawings, they're detailed, they contain all necessary information, can construct from it, it's accurate and precise, easy to communicate to manufacturers, but you kind of need specialized skills such as CAD. You need specialized equipment, it's time consuming and not easily understood by a layperson or a client. It can be quite confusing. Isometric drawings, you can see all views at once. It's easy to communicate with manufacturers and clients, but not all details are included and may not look like the real thing because of the dimensions are not true. Needs specialized skills such as CAD, and specialized equipment is needed. Perspective drawings look like the real thing in pictorial form. It's easy to communicate with the client, but there's no details like dimensions, and it's quite time consuming. Assembly drawings are easy to communicate with manufacturers and clients. They show how products could be assembled, but again, a disadvantage, they're time consuming and you might need specialist knowledge and skills. Freehand, it's quick, it's easy, no specialized skills are required, no specialized equipment is required, easy to communicate with manufacturers and clients, and it allows spontaneous, creative, divergent thinking. But it may not look like the intended outcome. and it might lack detail. All right, thank you for watching.